So we are going to begin Unit 3 on functions. And in this video, we're going to identify what a relation is, what a domain and range within a relation is, and how a relation is a function. So let's first give a definition for a relation, which is simply put a set of ordered pair. So a set of ordered pairs. So for instance, I might, as an example, have something like 2, 1, then 5, 9, then 6, 4, and then let's say 3 and 8. So I've got a set of ordered pair here. Then within a relation, we have what's called a domain. So simply put, a domain is just your x value. So in this example of a relation, my domain here would be all my x values, and I would state them from least to greatest. So it would go 2, then 3, 5, and then 6. Simple enough. And then my range, hopefully maybe you're kind of either A, remembering, or maybe guessing that your range is your y value. So in here, in this example, my range would be all my y values from least to greatest. So it would go 1, 4, 8, and then 9. And then finally, a function is simply a relation in which, where every, oh, I just spelled every wrong, whoopsie. Let's go back, erase that. So where every domain has exactly one range, has exactly one range. Okay, so in this case, this would be a function, my example up here, because every, like 2 is paired with 1, 3 is paired with just 8, 5 is paired with 9, and 6 is paired with 4. So there is no domain that's paired up with multiple ranges. So then in number 1, all we're going to do is identify the domain and range of that relation. So let's see, my domain would be, let's say we'd start with -3, then 0, then +3, and then 12. And then my range would be -8, 0, 4, and 9. For number 2, it's actually nicely organized for us with the x's and the y's, so it's just pretty easy. We just have to put it in least to greatest. So it'd be -5, then 1, 6. Now 6 is repeated, right? We see 6 here and we see it here. I only write it once though in my list. So if you feel compelled to, you can put like a check mark next to it and kind of like states to yourself that, okay, it's there twice, but I only have to write it once. Then 8, then 11. And then for my range, I would go ahead and put, let's see, go -10, 0, 2, 5, 8, and then 9. And then finally, number 3. This one's interesting because we have a graph. So what you might want to do is just kind of identify every point. So I know that D is at -3 and -4. I know that C is at, let's see, -2 and 2. I see A is at 4 and 4. And finally, B is at 5, -2. So it's a little easier now to write the domain and the range. So let's see, the smallest domain is -3. And then I've got -2, then 4, and then 5. And then my range would be, let's see, our smallest is -4, then -2, then 2, and then 4. So all my y values, okay? So again, these are my x values, and then this is my y value. Values, it's plural. So we use this information to also represent a relation, which here's my relation in number 4, okay? Whoops, I didn't mean to move the screen. Where's my little tool here? Okay, here's my relation. So I'm going to represent that relation in what's called a mapping diagram. We're all familiar with a table and then also a graph. So for your mapping diagram, what you'll do is you'll put your domains here and your ranges here, and we just kind of pair them up. So my domain from my relation here would be in least to greatest is -2, -1, 0, 3, and 6. Then my range is -5, -4, 5, 6, and 8. And then so what I'm going to do is I'm going to look over at my relation right here. Sorry. So I see 3 is paired with 6. And so what I'll do is I just create a line that goes, pairs 3 with 6. Then -1 is with 5. 0 is with 8. -2 is with -4. And then 6 is with -5. And that's it. That's a mapping diagram. So then in a table, I'm also going to just put my domains from least to greatest here. So I've got -2, -1, 0, 3, and 6. And then again, just looking over at my relation here, that's how I'm going to, determine, okay, -2 I see is paired with -4. So then I would just put -4, -1 is with 5, 0 is with 8, 3 is with 6, and 6 is with -5. And then finally, I'm just going to graph those points. So I've got 3 and 6. Then I've got -1 and 5, 0 and 8, -2, -4, and 6 and -5. And that's it. So that's how I would represent a relation in 3 different ways. So looking at the next page, so if you flip over your notes, we're going to, that is actually not the right page. Sorry guys, I gotta find this. So I'm gonna zoom, here we go. Nope, that's not it. There we go. Okay. So if you flip this over, what it's just trying to show you here at the picture is that a function's really, it's kind of like a machine. You put something out, or gosh, you plug something in and you get something out. Okay, so we can determine if a relation is a function by using our 3 methods of representing a function with our mapping diagram, a table, and a graph. So let's just go ahead and do that really quick. Let's take our relation that we've got here and let's put it in a mapping diagram. So my domain looks like is -3, 1, 2, 6, 6, and 9. And then my range looks to be like 0, 1, 5, 8, and 9. And then I'm just going to make my pairs. So I see that -3 is paired with 8, 1 is paired with 0, 2 is paired with 5, 6 is paired with 1, and 9 is paired with 9. So I'm also going to fill out the table. So I've got, okay, -3, 1, 2, 6, and 9. And then again, I know -3 is paired with 8, 1 is with 0, 2 is with 5, 6 is with 1, and 9 is with 9. And finally, our graph. Okay, so I've got 6 and 1, 2 and 5, -3 and 8, 9 and 9, and then 1 and 0. So now that we can see our relation being represented these 3 ways, I can determine if it's a function or not. And I do know that this is in fact a function because I would state every domain has exactly 1 range. So every domain has exactly 1 range. Okay, so every number here is paired up with only 1 number. Okay, so for instance, so like 3 only goes to 8. 3 is not also being paired with 0, it's just going to 8. 1 is paired with 0. 2 is only paired with 5, and so forth. Okay? Another reason we know that this is a function is if I look at my graph and I use what's called a vertical line test. And so I'm actually going to use a little lightsaber here. Okay? So I literally take a vertical line and I pass it through my graph. And if at any point it passes through more than 1 point at a time, it's not a function. But see here, I'm only crossing 1 point. I'm only crossing 1 point. I'm only crossing 1, only crossing 1, and so forth. So it passes the vertical line test. So for that definition here, here's what we're going to write. We're going to say if a vertical line, line passes okay, through, only one point. I'm going to put at a time. It is a function. So it passes the vertical line test. And that's actually another reason why you would explain if something is a function or not. So then why don't you guys try the next one on your own? So in number 6, your domains would be -8, -2, 4, and 7. Now I see 4 is up there twice. I only write it once. And then I've got 0, 1, 3, 6, and 9 for my range. I see that -8 is paired with 1, -2 is with 3. Let's see, 4 is with 0, but it's also with 9, and 7 is paired with 6. So before I even go on to the table and the graph, I know it's not a function. And I would say because domain 4 has 2 ranges, and I should only have 1. Okay, so again, I'm going to use a little, here we go. So 4 is trying to go to 0 and it's trying to go to 9. Okay, it should only have 1 range if this is a function. So then also as the table, okay, we would show it as, let's see, we've got -8 is with 1, we've got -2 with 3, 4 is with 0, 4 is also with 9, so that's another way of seeing it, okay? And then 7 and 6, and then finally our graph would look like this. So here's 4, 0, -8, 1, -2 and 3, 4 and 9, and 7 and 6. So if I were to do my vertical line test, okay, here it passes, but then right here, see how I cross 2 points at the same time? It fails my vertical line test. So like I was saying earlier, okay, like I was saying earlier, a function is just like a machine. You plug something in and you get one result out. So this happens in the real world. That's what we got down here on our notes. So an example of a real life function is if I go, to the vending machine here at school. I put in some money. If I click for, a soda or a water, that button gives me one result. Okay, it shouldn't be like a surprise. Same with like your remote. If you dial in a number to go to a certain channel, it's going to go to that channel. It's not going to be maybe, if I put in the number 9, I know that goes to WGN. It's going to always go to WGN and not surprise me, and maybe it'll come out to be, Disney Channel, okay? And also your weekly salary or your hourly pay is consistent at a job, right? I'm not going to pay you $5 and then maybe $10, okay? It's consistent. So come up with another real life example if you can, and then check back in to see what I come up with. So another example of a function in real life, you use this every day, is, well, your phone, but also your calculator.